So in this video, we're looking at a window switch, and we're going to bench test it. We're going to look at how it works, and we're going to look at what goes on inside of it, what fails. This is a non-multiplex window switch, so it's old school design, traditional. Like you see here, this is how it's wired up. Normally grounded contacts, so the motor is usually grounded on both wires. 2-wire motor. Power and ground will send power, and if you reverse the polarity of power and ground, it'll reverse the glass direction. This is what a failed contact looks like. This is one of the contacts in the window switch not allowing it to go down. You see it there in the schematic. This is the operation of the window switch with inside with parts off of it. This is what you're pulling up and down on to get the window to go up and down. You see the 4 contacts. That's a good contact. Doesn't look great, but it was working in that window switch. It's a master window switch. Right here, I'm actually ohming out off the car the vehicle contacts, outputs to the actual window motor from the window switch. See if I have continuity. We're going to test it right now. Make sure your leads have continuity. Nothing worse than having your ohmmeter leads not be okay, and then you're just chasing your tail at that point. So now that I know that I have good continuity, showed 1 ohm. Okay. Checking it here. I've got continuity. That's what I wanted to see. At this point, I'm going to check this ground, and then one of the wires to the motor contact terminals. So I'm checking an input and an output. I'm going to see if I have continuity there as well. You see I do. Less than 1 ohm. Next, I'm going to operate the window switch up and see if I have continuity from the power input to the output to the window motor. And again, there's only 2 wires to operate the window motors on this vehicle. I think back in the 50s and 60s, electric window motors were 3-wire, possibly a common ground and then 2 wires, but nowadays every window motor I've ever seen is 2-wire. Unless it has a module built into that window motor, like some European cars, then you might have many wires. So I'm checking continuity on the other contact. I've got 3.5. That switch is the one that would not bring the window down. You see it's not below 1 ohm. It's 3.5 ohms. Right there, it was okay if you do a diode test. Now I'm on a diode test right there, so it's not ohms, it's really current versus voltage drop. I do that sometimes because it puts a little bit more load on a circuit. So technically, it had continuity. You may be misled if you're using a meter and you see that you have 3 ohms instead of OL and say, okay, well, it's not the window switch. Maybe you use a diode test. It has continuity. It's not the window switch, but you're not checking it with enough current going through that window switch. And so this is a good example of why you should check circuits on the car, back probing everything connected with the voltmeter, because that ohm meter showed continuity going down and up, but I know the windows don't go down. I also know that this window switch is bad, but I just want to make this video to just kind of show you really shouldn't be using an ohm meter to test switches that have a lot of current going through them, like window motor circuits. If it was just a multiplexed, low current, low load switch that went to a module and the module turned on the power and ground for the 2-wire window motor, that might be different. But in this situation, I'm using a headlight bulb because I know a lot of current's going through those contacts that you saw that were burned out. So the front contacts work for up and down. Orange wires you see on the left, that's my little battery that's giving it power and ground for input to the switch. Right here, I'm going to start taking this window switch apart. I know that with the headlight bulb simulating the window motor, I for sure have a problem with the switch because the bulb wasn't lighting up for actual downward movement. So again, you saw the contacts that were burned up for the downward movement of the window motor. So that contactor is bad for both. Taking this window switch apart, be careful. If you plan on putting it back together, if it's okay, it may not work again. This is a 2007 to 2016 Patriot compass design. So the Patriot and compass window switch should be the same. A lot of that car is the same as one another, but I noticed that these window switches were pressed in and not soldered into the circuit board, probably to save money, and that's also going to add to issues. A couple of them just fell right out. They didn't seem to be burned up where they pressed into the circuit board, but they're definitely, not supposed to be that loose. So another good reason on this vehicle, this design, not to, slam your switches up and down, especially up. Right here I'm trying to figure out how to actually get this thing apart. There's no instructions on how to take these things apart. They really don't want you taking things apart. They want to sell you parts. They don't make these things easy to work on. A good example of that is Chrysler. When they manufacture an engine computer, they put gel on some of the circuitry that they say is to help with heat reduction in the engine compartment to save the life of the electronics, but it actually can be really difficult to try and fix at that point. Doing some research in circuit board design, car companies are doing more and more layered circuitry. So one thing that they'll do is try and hide with special pastes and compounds. They try and block images from x-ray machines so they don't see the traces when they x-ray circuitry, to try and reverse engineer or copy a circuit board design in a computer. So if you start seeing certain pastes or certain shielding, it might be for preventing reverse engineering. So none of this stuff is ever really considered serviceable. At the same time, you see a lot of circuit boards and computers that are sold by companies, part stores, remanufactured, rebuilt PCM. Well, a lot of those computers are not being fully repaired. In fact, they're just heating up the solder. Some of these companies putting new solder on and then calling it a day, making things worse because now they didn't use the right solder or heat it up right. It's pretty rare to see new processor chips put in some of these circuit boards too as well. So my advice is maybe find a good electronics engineer and ask him if he's comfortable repairing an automotive part. You're seeing more and more YouTube channels of guys that are smart enough to take a circuit board apart and actually repair a vehicle circuit board. Now, capacitors are the first thing to wear out on circuit boards, like if it's an engine computer, in my experience. But you have other things that happen. Do you need to replace every part of that circuit board? No, because if in that case, it's going to cost too much to do that. So you just go in there and you replace what's worn, and you kind of hope for the best, and you see what wears out.